Alright, welcome back to Master Video Tutorials. Now, in this video, we are going to look at the unit, circle, and circular functions. The unit, circle, and the circular functions. I'll be taking my time to explain to you how you can derive the unit circle of head. How you can derive the unit circle of head. And also, we will be looking at how to evaluate angle, all right? How to find the exact value of an angle. Very good. So let's start. Where are we starting from? All right. So from this figure here, this is what we call the unit circle. But this is the unit circle at the standard position. This is the unit circle at the standard position. Now, don't forget that you know that arc length, which is S, is equal to R times theta. R times theta. Very good. So here the S here, our argument the argument we are representing here is the arc length X. Sorry for this. The argument we are referencing here is the arc length X. Very good. So that is what we have for that. That is what we have for that. So this is the unit circle at the standard position. Alright. So now here it must also be taken note that if S is less than 0, sorry, let me take it from here. Know that it is starting at 1, 0. It is first starting at 1, 0, then it's measured like that. But take note that if S is greater than 0, then the arc length is measured in a counterclockwise direction. Make sure that you write that down. Put that down. Alright? If X, that is the arc length, is greater than 0, then the arc is measured in a counterclockwise direction, and that is the anti-clockwise direction. That is anti-clockwise and this is the clockwise direction. Very good. And if the arc length X is less than 0, then the direction is clockwise. So if it's greater than 0, anti-clockwise or counterclockwise. And if S is less than 0, then we have clockwise direction. Very good. Now, what if the arc length is equal to 0? Now, we all know that if the arc length is equal to 0, then no arc is measured. No arc is going to be what? Measured. There is no arc, alright? That is, there will be no angle for that. That is going to be what? Measured. Very good. So we are going to let the end point, alright? We are going to let the end point of the arc be at the point X, Y, alright? So we know that this is the terminal and this is the one. This is the initial and this is the terminal. So we are going to let this end point represent X, Y. X, Y. Let me write it more so that you can see X, Y. So this X, Y is the end point, alright? Now, it's also necessary for you to take note that take note that the X here represents cos X, whereby the X is the arc length, alright? Very good. And the Y is equal to sine X, whereby the X is also the arc length, that is the arc length. Very good. So please take note here for me that X is cos, Y is sine. X is cos, Y is sine. Very good. So for a unit circle to be in the standard position, that means that the unit circle is going to be equal to x squared plus y squared, which is equal to 1. I'm sure this is not your first time seeing this. Alright? From your previous knowledge in geometry. Maybe 1 or 2. Geometry 2. Geometry 2, yeah, geometry 2. When you were learning about the conic sections and all that. Very good. So that is that. That is that. That is that. Now, here the point here is 0, 1, the point here is negative 1, 0, the point here is 0, negative 1, the point here is 1, 0. That's the starting point. Okay, so then we will be moving to learn how to get the unit circle at every angle measured, alright? Because we can get the angle, say 30 here, sorry, 30 degrees, we can get 45, we can get 60, we can get 90. Oh, for 90 we have it. For the angle to be 0, we have it. For the angle to be 180, we have it. For 270, we have it back. What about the rest? We'll be looking at it. Alright, very good. So let's move to circular function. Circular function. Now, we saw in our jet representation, that the radial measure of theta is related to the arc length x. In fact, for theta measured in a radius, we know that x is equal to r theta. That is established already. Very good. Now, here we are going to assume our r to be equal to 1. Alright? We are going to assume that r is equal to 1. We know that if x, which is the arc length, is the argument, then sine is going to be y over r. Is that also? And cos is going to be s over r. And tan s is going to be y over s. No problem there. Now, here we are going to, on the unit circle, we know that our radius is 1. It's not that we're going to assume. Sorry for that. It's not that we're going to assume because we know that a circle is in the form x squared plus y squared equal to r squared. Alright. And from the unit circle we have here, we see that the r, which is the hypotenuse here is equal to 1. Alright. So here is representing the r here. So here on the unit circle, take note, on the unit circle, your radius is 1. Your radius is 1. Alright, so when you put r to be equal to 1, you are going to get y here. If you put r to be equal to 1, you get s here. This one is going to be here as y over x. Alright, so that is what we have on the circular functions here. So now sine x is y, cos s, not cos x, but cos s is x, and cos s is y over x, where the x cannot be considered because for it to be considered, the function is going to be undefined. And you know that cosec is the reciprocal of sine, and that means that it's going to be r. Cosec is going to be r over y. R over y. So for such a matter, if you replace r by 1, you're going to get 1 over y. Don't forget that. That's what you're going to use on the unit circle. Very good. Sec is 1 over s, and cos is the reciprocal of tan. So that's going to be the same thing. So that is all for the circular functions. Alright? That is all for the circular functions. Now, since x represents the cosine of x, and y represents the sine of x, and because of the discussion that we previously did, alright, now we are going to look at how to convert from degree and radians. We have done that already, but we have done that already in, I think, the second part or the third part of our video in trigonometry. What we are going to do here is that we are going to look at it on the unit circle, alright? How to generate it, alright? I hope you know how to write the angle is not difficult, but if I give you something like pi over 3, what is it going to be? It's unless you go and what calculate before. But let's see how we are going to do it on the unit circle. So we are going to derive the whole unit circle and see what we are going to come out from it. And not only the degree and the radian that we are going to locate on the unit circle, we are also going to locate the point Fy. The point Fy. Please, I'll be explaining all these things, but don't forget that the F represents the cos, the Y represents the sine, and on the unit circle, the R is equal to 1. Thank you. Alright, so here we are. We are going to derive all the unit circle, okay? Very good. And that's it. So we know that this is a starting point. We have already established this. And this is coming from the standard position. Alright, the standard position. What we have here is 1, 0. And we can even prove that. It's just simple. We can derive that. Take your calculators. I would like you to take your calculators. I don't have one here right now, but please take your calculator and let's do something. We know that here the point is x1. Is that also very good? So if this is the starting point, that means that the initial point there is 0 degrees. Right? And 0 degree in degree is 0, in radius is 0. So for this 0 degree, that means that the arc length, which is the S, is 0. So this is going to be, the S is going to be cos S, whereby the S is equal to 0. And sine S is equal to 0. Very good. So that is what we mean. The X is cos S and the Y is sine S. How we can see that? Very good. So when you press cos 0, what will you get? Cos 0. And when you press sine 0, what will you get? Please, I'm showing you how to derive it. Alright? So cos 0 is going to give you 1. That is cos 0. That's going to give you 1. And sine 0 is going to give you 0. So that is where this point is coming from. We can do the same thing for this. This is, let me write this more. This is 1, 0. We can do the same thing for that. We know that the angle here is 90 degrees. Alright? And when we go in radian, it's pi on 2. Pi over 2. How do we do that? This is 90 degrees, right? So when you multiply by pi over 180, 90 times pi over 180 is going to give you pi over 2. So now let's do that here. Take your calculators. Take your calculators. Now here, press pi on 2, pi on 2. You'll be getting this value, alright? That is 1 0. Okay, it doesn't matter. You can put your calculator in degrees, but you have to make sure whether you are in degree or you are in radians. Alright, I taught you that when we were doing geometry 2. Okay, so if on the top of your calculator you have there to be D, that means you are in degrees. That means you are in degrees. Alright, and so if you have D on top, that means you are in degrees. So if you have D on top, you don't need to be using pi on 2, but rather 90 degrees. You press 90 degrees, then it is 90 degrees. But if you have R on top, that means you are in radian. So you use the pi on 2 and do it. Very good. So that is that for that. So when you do that, here is going to be, here is 180 degrees. Let me write it here. Here is 180 degrees. And we know that 180 is the same as pi. 180 is the same as pi. So whether 180 degrees or so it's the same thing. Let's go for this. This is 270. This is 270 degrees. And that is same as 3 pi on 2. And that is same as 3 pi on 2. How do we know that? Just multiply this by pi over 180 and you're going to get that. And this is the same as or 3 pi. So this is the same as 3 pi on 2. 3 pi on 2. Alright, so let's move on to find the points SY for the other angles. Alright. So we can get 30 degrees here, which is the same as pi on 6. That is when you multiply 30 by pi over 180. You know, you can get 60 degrees here, sorry. We can get 45 degrees here. We can get 45 degrees here, which is the same as pi over 4. Excuse me. Which is the same as pi over 4. You can get 60 degrees here, which is the same as pi on 3. Alright, that is when you know how to convert it, so I don't need to talk much. So that is that. Let's get them. So you can see that the interval from 0 degrees to 30 degrees is 30. And from 30 to this is 15. And from this to this is 15. And from this to this is 30. So from here to here, we move by 30 degrees. So here is going to be 120 degrees. Then from here to here will be 15 degrees. And when you add 15 to 120, you get 135. 135 degrees. And 15 to this, you get 1. That is going to give you 150. Here is going to be 150 degrees. That is when you add 15 to this. When you add 15 to this. So from here to here, from 150 to 180 is 30 degrees. So you can see that. Now let's look at it in radian. So when you do that, for the radian measure for 120, you are going to get 2 pi on 3. So this is going to be 2 pi over 3. And the radian measure of 135 is going to be 3 pi on 4. And the radian measure of 150 is 5 pi on 6. 5 pi on 6. Alright. We'll be looking at the coordinate side, but before that, let's get the angle and the radius. Very good. So from here, you know that here is 180. 180 plus 30 is going to give you 210. So that means that this will be 210 degrees. Add 15 to this, you get 235. So you get 235. Sorry, 225. That is when you add 15 to it. 225. And when you add 15 to this, I'm going to get 240. 240. So we get 240 degrees here. Very good. Or. So now let's go for the radius measures. Alright. And 270. Oh, 270 is here. No. That is 240. 240. Alright. Now for the 210, the radius measure is going to give you 7 pi on 6. You can pause the video and check your calculators and get the rest for yourself. Later you come back and check. Here you're going to get 5 pi on 4. Then for this side you get 4 pi on 3. Alright. Quickly, let's move to this. This is going to give you 300 degrees, 315 degrees. We get 320. Here maybe 330 degrees. Very good. Now we know that from here to here is 30, right? So this is going to give you 360 degrees. And then 360 is the same as 2 pi in radians. 2 pi in radians, don't forget that. So that is that. Or now this is going to give you 11 pi on 6. This is going to give you 7 pi on 6 or 4. 7 pi on 4 right now. Alright, give me for this one. That is going to give you 5 pi on 3. 5 pi on 3. Very good. So that is the angle in degrees and in radians. Now the rest is just simple. We are just going to look. We are just going to use our calculators and the circular functions to get the rest, right? And that is not difficult. And what you get for this side, please watch. What you get for this side is going to be similar to what you get for the other side, but it depends, alright? Also, take note that for the first quadrant, all students take calculus. For the first quadrant, all the trigonometric functions, they are positive. And for this, only sine and its reciprocal is going to give you positive. Only sine and its reciprocal cosec is going to give you positive. And for the third quadrant, only tan and cos, that is the reciprocal of tan, is going to give you positive. And for the fourth quadrant, only cos and its reciprocal sec is going to give you positive there. The rest is just a computation, alright? So it's not anything difficult. So take your calculators and let's move on. So we are going to look for the x and the y here. Then we look for the x and the y here. We look for the x and the y here. We have this already to be 130. We look for that here. Then we look for that here. Then we look for that here. We know this already to be negative 130. We look for, oh, the space is too small. Unless I shift my video small for you to see what is going to be here. I'll do that for you, don't worry. Alright. We know that from this side already. Very good. So now let's go for the point. Let's go for the point. Take your calculators and let's move on. Alright. Hope your calculator is ready. So now let's move on. So we know this already. Alright. Even if you press, we are saying that this and this is the same. Alright. Sorry. 360 degrees and 0 degrees, they are all the same. But when you come to radian, 2 pi is the same as 360. Right. Now this means that when you press cos 360, you get 1. But when you press sine 360, you get 0. Because the 360 degrees and the 0 degrees are coterminal. I have taught you that. So So let's move on to this. Now, let's go for the x, which is the x is equal to cos. Let me write it boldly here. Very good. We move on. Alright. So let's go. Now for x, we determine it by cos s, and we know that the arguments here they are all s, which is the arc length. So what is going to be cos s, which is 30 degrees. So just press cos 30 degrees, and without any doubt, your calculator cannot lie, alright? So when you press cos 30 degrees, that is going to give you square root of 3 over 2. Square root of 3 over 2. And you know that all the trigonometric functions defined here is positive. So no problem there. Then you press on sine 30 degrees. And that is going to also give you half. That is also going to give you half. Then you move on to 45 degrees to be the x. So what is cos 45 degrees? And that is going to give you square root of 2 over 2. And sine 45 degrees is also going to give you square root of 2 over 2. Alright. Then we move on to this. Cos 60 degrees is half. And this is also going to give you square root of 3 over 2. Oh, you see, you don't need to memorize these things before you can derive it, alright? You can derive it based on your idea in circular functions, alright? Very good. You can also use the reference angle idea. I hope you haven't forgotten it. You can use the reference angle idea. Very good. Now let's move on. So here we are in use of only the sine and the cos. That is x and the y. Let's move on to 120 degrees. Now here, excuse me, you have to take note that in case you are using the reference angle, then you know that sine is going to be negative. If you are not using that, no problem. So you can take your calculator and press on cos 120 and see what that is going to give you. And that is going to give you negative half over 2. Then sine 120 is going to give you square root of 3 over 2. Now watch something. You can see that this is similar to this. Just that here, this is negated. Alright, just that here, this is negated. Do you know the reason why? The reason is just simple. Alright, the reason is just simple. The reason is just simple. Because here we are saying that only sine is going to be what? Positive. That means that cos will be negative. That is why cos is negative. And the reference angle for 120 degrees is what? The reference angle for 120 degrees is going to be 60 degrees. Because you subtract 180 from, so I said 180. You subtract 90 degrees from this. And when you subtract 90 degrees from this, you're going to get the reference angle of, I'll do this part. Alright, so you can see that this is similar to this. The reason is that here sine is negative and cos is positive. Let's go for this. This 1, 2 is going to be similar to this. Just that here is going to be. So if you get for this side, getting this is not difficult. Alright. After this, know that it's the same thing, but you just negate the s here because only sign is positive. Only sign is positive. Now, this also is going to be similar to this, just that you will negate this. I hope you are getting it. Very good. So this is the same thing, this is the same thing, and this is the same thing. Very good. So after getting for this side, you don't need to be memorizing for the second quadrant. The second quadrant is just coming from here. Alright. 45 is the same as 120. 30, 125. Sorry, 30, 150, 135, 45, 60, 120. Alright. Let's look for this side. This side, this is going to be the same as this. This is going to be the same as this. Let's see. You can see that here is the only place that you're going to use the calculator. This side, no problem. Now let's go for this side. Alright? Let's go for this side. Here, you can use the reference angle. You can choose not to use the reference angle. You know the reference angle for 210. 210 is going to be, that is, when you subtract 180 from this, you're going to get 30 degrees. So 30 degrees is the reference angle, right? So when you press cos 30, what will you get? Alright. You can, in case you don't want to use that, just press cos 210. And I'm sure you're going to get negative square root of, oh, let me shift my camera more. Alright, so here is going to be negative square root of 3 over 2. Negative square root of 3 over 2. And here is going to give you negative half because only tan is positive, that means that sine and cos is going to be negative. So just press cos 210, cos 210, you get it. And sine 210, you are going to get negative half. Note that both is going to be negative. Very good. In the same way, this is going to give you negative square root of 2 over 2, then negative square root of 2 over 2. Alright? Very good. Let's move to this. Press cos 240. Cos 240. And in the same way, the cos side is going to give you negative half. Then the sine is going to give you negative square root of 3 over 2. Negative square root of 3 over 2. So that is that for that. That is that for that. Now, as we discovered here, this is similar to this. In the same way, this is similar to this. But please, I beg you, don't be using the reference angle here. If you use reference angle here, you're going to get different values. On the unit circle, don't use the reference angle here. Here you can point here on calculator. Here don't point on calculator. Just relate it to this side and go your way. Very good. You can also choose to point it on calculator, but I'm teaching you in such a way that you can get it up here. This side too is similar to this. Here you can use the reference angle. Here you can use it. Here you can use it. Because when you press on, subtract 180 from this, and that's going to give you 30 degrees. And when you press cos 30 degrees, you're going to get square root of 3 over 2. Then you realize that on the third quadrant, cos is negative. Then you negate it. The same way for sine. Alright, so let's derive the one on the fourth quadrant. Then we close. So let's look at this. This is going to be the same as this, but on the fourth quadrant, only cos is positive. So here is going to be the same thing. Here, we're going to get square root of 3 over 2, negative half. The same thing. Here you get square root of 2 over 2. But here is going to be negative square root of 2 over 2. Then here is going to be similar to this. And that is half negative square root of 3 over 2. So that is what we are going to talk about. Very good. So that is all. And don't forget, this is similar to this, and this is similar to this. So just know for here and here, and you can get here and there. Very good. We'll be now looking at, we are moving on to how to evaluate, all right, how to find the value of the circular function. So let's look at about 5 examples in the close. All right, here we have to find the, okay, we are evaluating circular functions. So right now, don't forget all the circular functions that we derived. Here we have to find the exact value of sine 3 pi on 2 and cos 3 pi on 2. And we also have sine 3 pi on 2. Very good. So, solution. Let's look at how we evaluate it. Now, don't forget that in evaluating a circular function as a real number, let's say 3 pi on 2. Now, you have to know that this 3 pi on 2 is equivalent to evaluating it at 3 pi over 2 radians, because this angle, this argument is a radian measure. Alright. So the angle of 3 pi over 2 radians intersects. Now on the unit circle, you can see that the angle 3 pi on 2 you can see that the angle 3 pi on 2 intersects the unit circle at a certain point. And what point is that? Let's go and check 3 pi on 2. Let's look at it. 3 pi over 2. Oh, 3 pi over 2 is the same as 270 degrees. In degree we have 270, in radian we have 3 pi over 2. So you can see that it intersects on the unit circle at x-axis to be -1. Alright? And you know that at x-axis means that we are taking cos of 3 pi over 2. And that is going to give us -1. And on the y-axis, the angle 3 pi over 2 is, sorry, is going to be sine 3 pi over 2. And that is 0. So what are we called to investigate on this 3 pi over 2? Okay, so you can see that sine 3 pi over 2. Oh, that means that the result for this is simply going to be -1. Yes, just that. It's just going to be -1 because, sorry, I said -1. 0, 0, 0, 0. Because the sign represents the y-axis, and that is 0. Alright. And for the cos, that is going to be -1 because it intersects on the x-axis at -1. Oh, what are we going for now? Oh, time. Don't worry. We can get a time also. From our circular functions, you know that time is equal to y over x. Is that also? That is so. Okay. Tan s. So therefore here tan s is just going to be equal to, you know that the x here is 3 pi over 2. I like this. So to get y over x, know that this represents the y, this represents the x. So the y is 0. and the S is -1. So y over x, yeah. So the y is 0 and the s is -1. So what is 3 pi over 2 is going to give you, you know that 0 over -1 is going to give you 0. Alright. But excuse me. If let's say we have cos 3 pi over 2. Note that cos is s over y. Okay? Oh, I made a mistake. The sign on is rather negative. Let me check something here. There is a mistake on this particular circuit theorem. Let me check that and correct it. Oh, that is it. Please correct that for me. Oh, it's rather 0.01 because we are on the y-axis, so the x is 0. That is why I'm making a mistake here. -1. And here will be -1 because here the y here is negative values, okay, on our ON and OY coordinates. We know this. In fact, I'm sure some of you realize that you have done the correction. Thank you for that. Please, sorry. So that's how you do it. 0 -1 here, 0. Oh, so therefore, oh, this correction. No worry. So therefore, the sign is -1 here, and this will be 0. Alright. So for us to look at, hope you are not going to. I'm very sorry for that. And for us to look for tan, that is going to be, know that this is the y and this is the x. So the tan will be y over x. Therefore, the y is going to give you -1. And s is going to give you 0. So you can see that for tan, this is going to be undefined. Undefined. So for tan 3 pi on 2, you are going to get it to be undefined. Undefined. Very good. Thank you for the correction. Here is 0 -1, here is 0 1. Alright, thank you. Now let's move on to see if we can get our next question. Okay, so let's look at this. Question 2. Question 2 will be how to find the exact value of you have to find the exact value of 7 pi over 4 and then sine 7 pi over 4. Alright. So we move on. We know that 7 pi over 4. Which quadrant will it be? Because you have to get this object. Now, know that 7 pi over 4, in case you are not getting it well, you can do that. Multiply by 180 over 5. And what is that going to give you? So 7 pi over 4. 7 pi over 4. So when you multiply this, you're going to get 315. So that will tell you that it is on a 4th quadrant, and that is between this and this. So that one is added with it. Alright. So this is also going to be the same as 225. Alright. And that is this. So like what I said, this is similar to this is similar to this. Alright? Very good. So, you know that the point at 75/4 is 315. 315. So for cos, which is going to be x equal to cos 75/4. That is going to be at 75/4. The x is square root of 2/2. Because once you know this, you should be able to relate to this. And for sine, which is y is equal to sine 75/4. That's going to be negative square root of 2/2. So that is what we have for that. That is what we have for that. And on the fourth quadrant, you know that only cos is positive. That means that y is negative. Let me see if we can get our next question. Okay, what about if we have to find the exact value? We have to find the exact value of tan negative 5/3. Tan negative 5/3. Alright, now you have to know that the angle of negative 5/3 radius and pi/3 radius are coterminal. Because we have learned coterminal angles, so you have to be able to know how to relate these things. Okay, they are coterminal. How do we know that? Alright, you know that negative 5/4. For you to know that this is a coterminal, now you can multiply negative 5/3, convert it to degrees. Okay, when you convert it to degrees, in fact, we have done coterminal angles. I don't need to talk on this. Convert it to degrees and be adding till you get a positive value. And you can see that the positive value that you are going to get is going to be 60 degrees. So this is coterminal to what? 60 degrees. And 60 degrees is the same as pi/3. Alright, so that means that we are, so solution. Negative 5/3 is coterminal. So you go for the coterminal angle. It's coterminal to pi/3. And since it's coterminal to pi/3, you go to your unit circle. Then you indicate, because you know that tan S is y/x. So you need to go and indicate the x. So pi/3 is 60 degrees. The x is half. The y is square root of 3/2. So for you to get tan negative 5/3 is the same as square root of 3/2 times 2/1. Alright? And that is going to give you this cancels this, and that is square root of 3. Very good. Very good. So the tan negative 5/3 is going to resolve to square root of 3. Hope it's not difficult. Take your time and just know you are playing coterminal angle. So when you are given a negative angle, don't be there and be suffering. Alright? Very good. So that is that. Let's look at our next example. And it says use reference angle and degree or radian conversion to find the exact value of cos 2pi/3. Oh, no problem. Let's go for that. I hope you are done writing it. Here we have to use reference angle. Let me write it for you. Use reference angle. Reference angles and degree or radian. Radian conversion. To find the exact value of cos 2 pi. Alright, so in a question that, please leave this one for now. In a question that we just wrote, alright, where to use the reference angle and degree or radians convention to find the exact value of cos 2 pi over 3. Alright. Now, note that the reference angle, note that 2 pi over 3 is the same as 120 degrees. And 120 degrees, the reference angle for 120 degrees is 60 degrees. Alright. So, if the reference angle of 120 degrees is 60 degrees, and you are to use the reference angle to evaluate, that means that instead of writing this, you write 60 degrees. But note that 120 degrees is in the second quadrant, and in the second quadrant, only sign is negative. Sorry, only sign is positive. So this is going to be negative. So this is going to be negative half. And that is that for that. Very good. Now, this I explained in the video, but the video just cut off while I was solving it. So I don't want to clean it. Let me explain to you. Now, yeah, there are sometimes that you see this in decimal place. This cannot be found. This argument cannot be found on the unit circle. So it's just by you using your calculator to make your answer. So just point this, then you write, but here we don't write equals because this is an approximated value. You are to, it's always advisable to leave it in 4 decimal places. So this is approximately that approximation sign. Right. So that is that right there. So that is that. And that is that for this one. And don't forget the unit circle, okay? If I'm to be used, the unit circle, when I get this, it's similar to the ones here. And when I get this, it's similar to the ones here. So don't worry yourself to choose everything. Thank you. Oh, sorry. Now, in the next video, we are going to look at the graph of the trigonometric functions for sine, cos, tan, and the rest. Thank you.